Good morning, everyone. This is Janet, I'm NRCS engineer in the Southwest area, Richland Center. And I've been with NRCS about 20 years. And I'm going to talk today about geotextile and then granular filters. In an overview, this is not a detailed design of either of these, but just to give a background, we have a lot of new staff with NRCS, and the counties might say the same. So thought it was time maybe to just give it a little overview of these two topics. So basically just want to talk a little bit about geotextile and where it's used in Wisconsin. And then, we usually use geotextile for a lot of our practices, but sometimes we may want to use a granular filter instead of geotextile, and I'll talk about when that would be the case. So geotextile, we all pretty much, I think, have an idea of what it does, but basically we want these fabrics to allow water flow, but hold the soil in place. And the water flow part is the drainage part. Holding the soil in place is called the filtering part. Geotextiles are usually very good at that. Granular filters can also be used for this type of purpose. And sometimes granular filters can actually be better, and I'll talk a little bit later about what those situations are. So then the other thing that geotextile is often used for is to kind of just separate and stabilize, and this is more of the roads, where we use it for roads. You want to keep a couple of different things apart. So for example, over here on the road, can everyone see my pointer? Jean, could you verify that? Yes. Okay, great. So, when we build a road, you're usually putting a granular sub base on top of the soil. And, depending on what kind of soil that is, that granular base can just continue to kind of get down into here. And an old adage about this is, you put 12 inches of gravel on 12 inches of soil or mud. Well, you're going to end up with a mixture of, both and get 24 inches of mud. So geotextile creates a nice barrier and also provides some reinforcement for that too, for that road. But its main purpose in the road is really to separate and stabilize. And this is a good, this picture down here, kind of shows without geotextile how that granular material can get down into your soil, and then you're going to have depressions, potholes, etc. And that geotextile provides a barrier to that. As far as drainage and filtration, riprap is a good example of that, although, here at NRCS, we don't use geotextile a lot for riprap, but they do certainly on building roads. So the geotextile, here's your soil, you put that geotextile down. What it allows is it holds that soil in place, the filtration part, but it lets the groundwater, any seepage coming through, usually lets it come through. So the drainage and filtration, separation and stabilization, those are the big ones that we focus on here at NRCS. So everybody's probably heard, non-woven. We use that a lot, but there's also the woven type geotextiles, and the non-woven, feels more like a felt, and has this when it's made, it's kind of a random orientation of the fibers. It's not a pattern of any kind, whereas wovens tend to be more of a plastic feel because they're manufactured in a more of a pattern. The openings and how they're put together is more of a pattern, whereas non-woven is more random. And because non-woven is more of a random orientation, it's far superior for drainage, for letting water through, and for filtration, meaning holding soil in place. It can also be used for separation and stabilization, but honestly, wovens tend to be more better at that because they're stronger, just by the nature of how they're made. They're stronger. They don't have as much water flow. They tend to be more expensive, but they do have superior strength. And on a rare occasion, they do have a place here at NRCS. But honestly, I've never had a project that called for the expense of a woven material. And I'll explain a little bit more, like, where would we maybe use a woven material? But non-wovens definitely fulfill most of our needs here at NRCS, and they tend to be less expensive than woven materials. They do have less strength, but they have plenty of strength to handle what NRCS throws at them for most of our projects. So I just wanted to let everybody know there's a couple of resources on our ePhotog for designing geotextile, or not so much designing it, but how you would use it in a design. It's basically a selection guide, and that's in EFH Chapter 17, Wisconsin Supplements, on Section 1 of the ePhotog under Engineering. There's Engineering Field Handbook, and you'll go to Chapter 17, and there's a document in there, the selection guide for the use of geotextiles. And then for construction, everybody's probably familiar that we have a Wisconsin construction spec number 13 for geotextile. That doesn't cover so much, how do I pick a geotextile, but it does cover, what are the material requirements, how do I handle it, and how do I put it in? And there's a couple of tables in there that almost everyone, I'm sure, is familiar with. That's one's for woven and one's for non-woven, and it specifies all the strength properties and water flow properties, stuff we compare to our geotextile tags. And that's in Section 4 of the ePhotog. So as far as the manufacturers are concerned, they have definitions or functions of geotextile is how they define them. And the four big ones they use are drainage, filtration, reinforcement, and separation. Now, these aren't exactly the terms NRCS always uses, but I'll just go through. Drainage to the manufacturers is in the plane of the geotextile. So this gray part here is your geotextile. Let's say this is your subsoil, and maybe this is a granular road base up here on top. That drainage to the manufacturers is through the plane of the geotextile. And that's mostly for non-wovens. It's always for non-wovens, actually, because non-wovens are thicker than wovens, and water can flow through the plane of the geotextile. Where this might be used is you've got a road, and then you've got this geotextile layer, and you come out here, and where the road ditch over here hits, this will drain into that road ditch. And it's certainly in the plane. Now, how NRCS defines this is more like this diagram here, is water being able to either come up or go down through the geotextile. That's how we define drainage. It's through and perpendicular to the geotextile. Not this. We don't use this feature here at NRCS. But I just wanted to point out, because sometimes I think terminology, we get mixed up in that, like the manufacturer is saying, yeah, that's great for drainage, but what they really mean is it's great for horizontal drainage. What we want is we want vertical drainage. So filtration is the other one. They're on the same page as us about that one. That's this one here, fluid flow through it. You want fluid to go through it, but you want this geotextile to hold this soil in place so it's not migrating up, or vice versa. Whatever is here is migrating down into the soil. So that's holding soil in place, but allowing water to go through. That's basically the crux of filtration. And here at NRCS, we use filtration and drainage in combination with each other because of the nature of our projects. Reinforcement to the manufacturers is a couple things. It can be used in roads, but they also use reinforcement for like wall reinforcement, which isn't something we really use geotextile for here at NRCS, at least not in Wisconsin. So reinforcement to us is what we would call road stabilization. And essentially you want a geotextile that is pretty strong so that it can resist wheel loads. And as you can see, a wheel pushes down and it's pushing out on the geotextile, and it's, and this is, the geotextile is serving to resist those forces pushing out and to kind of pull things back together. So that's more of a tensile strength situation going on there. So reinforcement to them is something a little different. We call it road stabilization here. And separation, again, we're on the same page. You're just purely putting something in to hold a finer material, separate it from a larger material so they don't mix. So just wanted to point out, manufacturers look at function. NRCS took the functions and said, you know what, we're going to make this simple. We're going to define three uses that people can look at what their use is and determine what class of geotextile they need. And so or NRCS came up with three uses instead of functions. And slope protection, that would be the ripraps most often. Subsurface drainage, blind inlets. Road stabilization, access road, stream crossings. So slope protection, your big thing here is separation, filtration, and drainage are all important. Think about this along the slope of a bank and a stream. You want it to let water through, you need it to hold the soil in place, but you need it to separate big rock from soil. And I'll talk a little bit later about this, but things like permittivity and soil retention are key factors when looking at slope protection and which geotextile to pick. Although almost always a non-woven is going to be your best bet for a slope because the roughness of that fabric, remember, it feels more like a felt, not like plastic. So that roughness is going to provide a better bond with the base soils and with the rock, resisting the sliding of the rock. Subsurface drainage, that one's pretty obvious. Filtration and drainage, holding the soil in place, letting water through are its two key features, but also separating, maybe a granular material, drainage rock from the soil beneath it. Strength is not so much of a factor for subsurface drainage, the strength of the material. You more want something that is going to be able to let water through. That's what you're looking at there. And I'll talk a little bit more about, okay, so how do you decide, this one's better than that one as far as letting water through? We'll get into that here in a minute. So road stabilization, you're trying to separate basically a granular material from a soil material, and you're also looking to reinforce, how many times have we've seen roads, they go out and they dump rake or rock down and then, put a gravel over the top of that, and you come back in 6 months and you've got depressions in that because that there wasn't a separation between the soil and the breaker rock, and it just kind of mixed together and you get those depressions. That's where something like a road stabilization or class 4 is really helpful in preventing those depressions. All right, so we now know the uses. Well, you go into spec 13, tables 1 and 2, which is the tables we use to say, hey, contractor, that geotextile is going to meet our requirements or it's not going to meet. That's tables 1 and 2 in spec 13. And for the woven table, there's classes 1, 2, and 4. And over here, there's 1, 2, 3, and 4. And first off, you define slope protection is one of our uses. So that's a 1 and a 2. Road stabilization, that's a class 4. And same thing over here, except subsurface drainage is thrown in for the non-wovens. And, why doesn't the woven have subsurface drainage? Well, wovens are not the greatest for draining water, and they're not the greatest for filtering soils, meaning keeping soil in place, but they're really good at strength. So they have their uses, just not in subsurface drainage. So I'm not going to dwell too long on, where do these classes come from? In the tables 1 and 2 in spec 13, we've got classes 1, 2, 3, 4. Well, do we just make those up? Not exactly. We only made up one of them, kind of. The three, ASHTO is an organization, a professional organization for essentially road builders or highway professionals. So that's what ASHTO is. And they provide a lot of not requirements necessarily, but guidance on how to, requirements for some products and how to use those products. And one of those is geotextile, and that's ASHTO M288. And they've come up with 3 different classes, which NRCS does use. That's where basically the 3 classes we're using in Spec 13, that's where they come from. And as far as how ASHTO looks at these things like, grab strength, tear strength, puncture strength, and seam strength, that's how they define the survivability of a geotextile. And survivability is based on the time of time of construction, because that's when it will experience its worst loading, as far as, the big equipment driving, over the top of the geotextile, not on directly on the geotextile. You should never see anyone driving directly on a geotextile with any equipment. You should always have that protected with at least 6 to 12 inches of something before anyone drives on it. So that's a no-no to drive directly on it. Um, so the AASHTO tables, talk about the strength requirements that are related to survivability. Then they've got other tables 2 through 5 that set the limits on, permittivity is water flow, AOS is related to retaining soil, and the UV requirements. And I'll get into those in just a minute. What I wanted to point out here, when AASHTO, they determine classes, like class 1 is a high ground pressure equipment. So it says here it's a little over 7 PSI. Just wanted to give you an example. A 54,000 pound track hoe can put that kind of pressure on a geotextile. Cat D8 dozer, same thing. So class 1, that's why we almost always use class 1 or class 4 for roads, because you do have those high ground pressures from that type of equipment. So one more thing on AASHTO M288, just to kind of show you, that's where some of our numbers for permittivity and opening size, that's where some of that, a lot of that information comes from, is these other tables that are listed in AASHTO M288. All right, so when we're looking at AASHTO, or when we're looking at Spec 13, you know, AASHTO classes for non-woven are the same for 1, 2, and 3. And then class 4 for Spec 13 is it's the same thing as a class 1. And there's just a little bit of difference on the permittivity, which I'll get into in a little bit. But essentially, for non-wovens, the classes match up with AASHTO. But for wovens, they don't match up. And I'll get into here in a minute why that's important. But, the reason we typically, like a 1 here in woven is a 2 for us. The reason is these professional road builders are building roads that have really high traffic loads on them, and we don't build roads like that here. Our roads are more medium to light duty, so we really don't uh, need our classes here to match up with theirs for the wovens. Now, NRCS did take a class 4, as I mentioned before, and they modified it, created our own class 4 and modified it just specifically for our type of roads, the medium to light duty. AASHTO does has a class 4A, they call it. So, if you see on a geotextile tag that it says class 4A, that almost always applies to wovens because that's really high strength stuff and it's way beyond what NRCS needs. But I just wanted to point out, even though we have a class 4 here, it is not even close to what this an AASHTO class 4A would be. All right, so just to kind of define, what are some of these terms that are used in our tables for Spec 13? Grab tensile. What do these things mean? Essentially, tensile strength, puncture, and tear, those are the survivability requirements as AASHTO defines them. And essentially, they define how strong is that geotextile? How's it going to resist that load during construction? Those are important to us, but things that AASHTO kind of puts in their subtables that are less important, I guess, to road builders are things like apparent opening size. And this is what we need to have for keeping soil in place, that filtration feature. Permittivity is another one. That's the drainage one. Our projects, we like to be able to have drainage and soil retention as being 2 of our bigger things here. And what permittivity is just basically how much water can that pass? And oftentimes we run into the term permeability instead of permittivity. And essentially, if you want to know what the permeability of your geotextile is, you take the permittivity and divide it by the geotextile thickness. This geotextile thickness is available on most data sheets for most of our main suppliers. for geotextile. You have to kind of dig for it because it's not always on the first data sheet you'll print out that has all of this information on it, but it's out there. And the only reason this might be important is if you have, I don't know, more of a sandy material and drainage is important to you, and you know that sandy material has a permeability in a certain range, you'll want to make sure your geotextile is at least that high or higher than the soil permeability. So this is how you would figure that to match it up with the permeability of a soil, because soils aren't measured in permittivity, they're measured in permeability. But it's safe to say that non-wovens for most sands, silty sands, and silts and clays, non-wovens are going to have the order of up to 1,000 times the permeability of a soil. Of course, if you get more towards a clean sand, non-wovens aren't going to they aren't going to have that high of a factor of, they'll be more like maybe down in the 10s to 20 times. And, just want to mention that if you are putting a non-woven next to a gravel or a sand and you're counting on it for drainage, you'll want to make sure that your geotextile isn't holding things up as far as drainage go. Now, wovens, they're not so great at drainage. They use something called percent open area. Because of the way they're manufactured, it's more of a pattern, so you can determine what a percent open area is. That's really good for water flow, but it's terrible for particle retention. So, you aren't going to get the filtration part, but you will probably get the good drainage. But it doesn't matter because you're letting the soil through. So it's a fail on that part. One thing that's mentioned in Spec 13 is, what does protected mean? This class 2 protected. Well, first off, you can see here that a class 2 would be something that's not as strong. It's got lesser numbers on all of the requirements for strength than the class 1. So if that's the case, and you're using it for slope protection, like putting riprap, you don't want to be putting that big, clunky, heavy, sharp rock right on that geotextile. You have to protect it with what we call a sand cushion, and that's usually about a 6-inch layer of sand material, preferably a cleaner sand, but it can be pit run depending on what your situation is. You don't want a sand that's dirty though, because that'll clog your geotextile. So you want, a pit run if it's fairly decent on the, less, not as much fines, or just a straight up clean sand would be a good choice there. Now, the problem with that is, when you put that sand cushion on and you got this big void space rock riprap, that sand will leach right through unless you put what we call a graduated granular filter. And what graduated means is that you got sand, so then you're going to go up maybe to a ASTM C67 gravel. Then, if the gravel isn't big enough that it won't go through the riprap, then you got to put another layer, maybe a 3-inch breaker rock on top of that, and then put your riprap. So it can get to be a little cumbersome, and that probably explains why class 2 isn't used very much in Wisconsin, because there's some monkeying around with it to get it to not have your sand cushion leach right through your big rock riprap. So geotextile tags, I talked about the AASHTO classes, and oftentimes geotextile tags will list the AASHTO class, but we can't confuse that with our classes, because remember, for woven, they don't match up. They do for non-woven, but we have a class 4 for non-wovens that AASHTO won't mention on these tags. So, this is nice information to have, the tag and everything, but you can't approve the geotextile based solely on the tag. What you have to do is take that tag, print out the manufacturer's data sheet for that tag, make sure that all of these names of the properties, ASTMs, units, and numbers match whatever table you're using, table 1 or 2. In this case, this is a Mirify 180N, which is commonly used here. That'll be your, you'll tell you what the number is, so you can go, and then up here it tells you what the manufacturer is, so you can go right to their website and print out the sheet, compare it to the tables, and approve or disapprove it. Now, it's always a good idea to get this information from the contractor, not the tag necessarily, but say, hey, what are you planning to use out there? And don't let them just say, oh, well, the 8 ounce from CFM, because I've heard that many times. That's not good enough. What you need is the name of the manufacturer, and you need the name on the tag, the number on the tag. This stuff isn't something you need to approve it. It just talks about the width and the length of the roll. And documentation, right? Always put a copy of this in the landowner's file, and the tag as well. And don't think, a few months ago that 180N met, I don't need to check it. Well, you need to check it every time, because specs change on the manufacturer's end. Specs change on our end as well. I think the last revision for Spec 13 was in 2022. And prior to that, it was about 6 or 7 years, I think, before it was changed. But, our specs change, their specs change. So do this every time. Don't go off of past history. All right, just a couple other things from Spec 13 to check. 95% weight polypropylene, 100% virgin polypropylene. So things like that. You want to make sure it's made of the right stuff. And for non-wovens, for example, randomly oriented. Make sure it says random network or random something like that, that it's not a patterned, that this is all a random orientation of fibers. All right, so what are some problem conditions for geotextile? And I want to talk a little bit about this, because we're going to get into, well, how do I select a geotextile? And this is important. So geotextile, almost always works, and it works on a lot of our practices. But we have seen some spectacular failures as well on rock shoots, for example. And one of the reasons for that could be the type of soils that it was put upon. The other reason that I'll talk a little bit about later is that how it was installed wasn't really, it needed to be installed a little differently to make sure it didn't fail. So as far as the soils, we don't run into these very often, but this is probably the one you would most likely run into, is non-cohesive silts or dispersive clays, basically things that don't clump together. They're called mobile fines, meaning if there's any kind of water running underneath on top of that geotextile, it's going to carry those fines with it, and those fines will clog that geotextile. Another one we might run into is internally unstable. What that means is gap graded. And of course, if you have a gradation that you've done in the lab, that's easy to see. But in the field, basically you'll pick up a handful of this stuff. And if you've got a lot of larger particles and a lot of smaller particles, but nothing in between, that's gap graded. And that's not good. That's a bad gradation. And what happens is the fines can get into the geotextile and clog it. Another one that I've never seen, but I suppose it could happen, is where you have thin layers of sand, thin layers of silt, thin layers of sand back and forth, and it's just not a good soil to put geotextile against. And of course, our soil scientists always want us to talk to them about soils, so make sure you consult them if you have any doubt that you've got any of these type of soils. Other things too to consider is, the groundwater. Is it really hard groundwater? Meaning that calcium, that magnesium that's in there is going to be precipitating out, and it's going to be hanging on the face of that geotextile and clogging it up. Hard water. The other thing is, do you have dirty water that you're trying to, for some reason, is that dirty water that's up against that geotextile? That could be a real problem. The other thing is high energy water, and this really comes, not so much in Wisconsin, but maybe on the Great Lakes. You would have this thing where you have high energy water flows that are reversing all the time, and those aren't a good application for geotextile. So these soils that I talked about up here can cause something called clogging and blinding. I think most of us have probably heard of blinding for sure. Clogging is when the soil particles or those fines get inside that geotextile fabric and just, they clog up the openings through the geotextile. Blinding is when they accumulate on the face and they're basically creating a wall that water can't get through. So I'm not going to dwell on this very long. This complex chart is from the FHWA, which is the Federal Highway Administration. It's a document they put out, Geosynthetic Design and Construction Guidelines. Anyway, they came up with this design guideline for preventing clogging and blinding in geotextile. You need a soil gradation test to do it. And if you were to go through it all, you would have to, as far as spec 13 in your construction plan, you would say, okay, I'm specifying a different apparent opening size for this instead of the 0.22. It's got to be this number or that number. And you have to really specify everything for that geotextile. It is almost always better just to use a granular filter that I will talk about later, because I've gone through this process once and it's complex. And, the big thing is you need a soil gradation test. So probably better just to use a granular filter. So I just want to talk a little bit about how do geotextile weights affect properties of the geotextile. Essentially, if you have a lighter weight, 8-ounce geotextile, it is going to have better water flow because it has less fibers and it's just not as thick. And what it's going to have, though, is pretty darn good water flow because it's not as thick, because it doesn't have as many fibers. It's going to be more open. A heavier duty geotextile, 16-ounce in this case, you can see how all the strength requirements go up, but permittivity, or the water flow, goes down by half. So twice the weight, half the water flow, about twice the strength roughly. So, just remember that when they're saying, hey, I'm using a 16-ounce from CFM, and you're using it for subsurface drainage, which you need really good drainage, you're gonna be like, that's probably not appropriate. I should use probably an 8-ounce instead to get better, or even a 6-ounce to get better drainage. So I just wanted to point that out, that, the weight of the geotextile, and contractors often use weights. They'll say, I'm using a 6-ounce or 8-ounce, or, you can kind of get in your head, okay, road stabilization, that's okay because heavier is better, stronger is better. Subsurface drainage, heavier, not so good. So geotextile is used in several practices. I just want to go through a few of them. So I'm using the non-woven table here as a guide because we almost always use non-woven here at NRCS. I've never had the use for a woven product, not that there wouldn't be. We just don't need that kind of strength. It's more expensive and it doesn't drain as well. So let's take blind inlet, for example. This drawing spells out, class 3, and that's good because subsurface drainage is class 3. And it doesn't spell out non-woven. It should. You'll notice in some of our NSCS drawings, it'll say, yeah, class 3 non-woven geotextile, or it'll just say class 3 geotextile. It'll just say geotextile. And, we're left with deciding, what does that have to be? I'm actually going to try to make an effort to pick the type of the geotextile on several of our drawings and make sure it's on the drawing spelled out. But in this case, subsurface drainage is appropriate. It's a, class 3, non-woven's appropriate, drains better. And it says it's optional here, but honestly, geotextile is such cheap insurance for something like this, because then you don't really have to think too much about, the soils getting up or this granular material getting down into the soils and those mixing and then fines getting up into your pipe. We don't want that. If you have decent soils, meaning, not dispersive or gap graded, the problem soils we talked about before, the mobile fines, go ahead and put that geotextile in. It's cheap insurance. Rock riprap, that's one, we do have a drawing for it, but I don't know that people are using geotextile so much on rock riprap. And the reason is I think for a while, the thought was, we're putting these in at 1.5 to 1, 2 to 1. That's pretty steep. And, does it create a slip plane? Well, it's probably not helpful. Rock against soil is probably always superior to being on a fabric of some kind, as far as the rock wanting to slip down the plane or slip down the slope here. But if you did use it, the class 1 is appropriate, or the 2 protected. And The reason class 1 is used here is because it's just tougher. It's got tougher puncture than the class 2 or 3. Um, but it still provides some decent filtration and drainage, meaning it'll hold the soils in place, but it'll let water through. So, if you were to use a geotextile, it would be a class 1 or a 2 protected. And again, 2 protected isn't going to be used on these slopes much because, you're going to have to put a sand layer on top of the geotextile, and then you got to keep that from leaching through the riprap, and it's just not practical. So, all right, ground gutter is one, the water's coming in from the top from a roof gutter. So we spell out a class 3 here just because we always use class 3 is lighter weight, be cheaper, but could you use a 1 or a 4? Absolutely. Could you use a woven? Sure, because the only thing you're really caring about here is separation. You want to keep the dirt in the trench out of this clean stone. The water's coming in from the top and, getting into the pipe. So yeah, we'll probably continue to keep this as a class 3 just because it's cheaper, and why not, right? But you could use a 1, 3, or 4, meaning if you're out in the field and the contractor put a class 1 in, you can say that's perfectly fine. Okay, access roads and stream crossings. Of course, road stabilization, that's the class it would fall in. Again, if you're only looking at it for separation, meaning, I've got soil here, got my got my big rock here. You know what? A non-woven or a woven would work for that. But if you got any kind of moisture that you want to take care of under here, you want this to come in and go down through the geotextile into the soil, you want to be using a non-woven because drainage is far better with a non-woven than with a woven. But again, if the contractor throws in a woven, as long as it meets the strength requirements of the class 4 for woven, it's okay to stay in there. Grade stabilization. Now, this is a drawing that we're probably going to have to fix. And geotextile is almost always used. People just staple the geotextile to the back of the boards, and that works great almost always. Unless you got those problem soils back here, your geotextile will be just fine. That's the one to use. It's a class 3 because you're obviously trying to let water that's coming down through here up against these boards, you're trying to let it out through the weep holes. So you'll want to use a class 3 here, plus it's cheaper than any of the other classes. Now, the problem I have with this drawing is a gravel filter. We'll talk about that one in just a minute, but that's not a real practical application here unless you have problem soils, but I'll talk about that one in a minute here. I want to just talk about road stabilization first. Like, we have this class 4, and it's essentially a class 1, but permittivity is less. And, why that is because when you get a class 4 or something that contractors are using on a road, it's almost always going to be way high. The numbers are going to be way higher than these. They're going to be like double these numbers. They're going to be more in this range. Well, or higher. Let's say, this is even 600 pounds here. And what happens as these numbers go up, this number goes down. So what we decide, or, NRCS is doing here is saying, we know that contractors, this is all they have to meet, but they're probably going to, because they build roads other places besides NRCS, they're going to be using something that's a lot stronger than this. So it's going to have a lower permittivity. And sometimes that permittivity number, although my example doesn't show it, can be less than this 0.7. And we don't want to reject it based on that alone, because permittivity, water flow, if your main use is road stabilization, that's not as important. These are important. And that's why permittivity was lowered on the class 4, because water flow isn't as important. Just remember, heavier weights, stronger geotextile, less water flow. So access road standard mentions things like somewhat poorly drained. And when you start getting into somewhat poorly drained and poorly drained, you start seeing the geotextiles show up in the options. The class 4 is appropriate. It's a road. And typically, as you can see from this table, geotextile can be used to replace, 4 to 6 inches of stone. And we almost always use class 4, but class 3, they show this one class 3 down here can be used, and we're like, wait a minute, class 3 is for subsurface drainage. It's not very strong. Why would we want to put that in a road? Well, that's because you have to use it with geogrid. Well, geogrid provides the reinforcement or the strength. Therefore, the class 3 is just providing separation and drainage. So that's the reason a class 3 is okay in this situation. It's because, if you've got a really wet site, you might want to consider this, because this will be a better draining than the class 4s. So, really wet sites, maybe consider this. And again, I suppose wovens could be used here, but again, they tend to be more expensive and overkill for the type of light duty, medium duty roads that we're building. Stream crossings in the standard, there's table 2, and then some comment about using geotextiles to improve foundation bearing capacity. Well, what that means is, if you've got a super soft foundation, let's say, you poke a probe down in the stream bed and you're going all the way down 3 feet before you're hitting anything solid, you might want to consider geotextile there, because the cost of bringing in 3 feet of stone of different varieties could be cost prohibitive. And if you do that, you can do 8 inches underlaying with geotextile, for example, in this case, or 18 inches. But, it's for these really soft sites. We all know that putting geotextile in the stream can be a bit of a pain, but you can save a lot of, you know, putting granular material in there. And sometimes granular just isn't going to work because you can't get to anything that's firm, or the firm is deep. And I just wanted to point out here, we talk about soft foundations, firm foundations. Well, how do I know what that is? Well, there's actually a table in chapter 4 of the National Engineering Field Handbook. And this is the table, and this describes, soft. Can you stick your thumb down there for an inch? That's soft. Very soft is more than that. Firm is, you can't go in very far. So that's the relationship of soft and firm of what they're talking about in the stream crossing standard. Toe walls, this one I brought up before. What I don't like about this filter thing is, this is in the toe wall drawing, this is the definition of the filter. But that's not very good, because a design filter, needs to have a good gradation of usually just sand. It's Gravel is not something you would use up against a soil, because I don't know of too many soils in Wisconsin that won't just migrate right into gravel. And I think the intent here is to use a combination, but when we talk a little bit later about granular filter design, which is what this is showing here, when we talk about that, it's almost always going to be a sand up against the soils we deal with on a daily basis. So I'm going to have this talk to Steve about Steve Becker, our state engineer, about redoing this, as far as this isn't a good filter right here. So essentially, if you got too much gravel, well, the soil's going to go through. So, and then the other thing right here, geotextiles. So class 3 is best, but if any of the other classes used, it should be okay too, because in this situation, I mean, if you've got a lot of seepage coming through here, you should be putting a tile in to get that drainage out and around that toe wall. So for the type of drainage, just basically relieving hydrostatic pressure behind this wall, that's not a lot of water. Any of the classes of geotextile will work. I mean, 3 is cheapest. It's got good drainage, works well. But if they used a 1 or a 4, go ahead. It's fine. It's fine, because it only has to let out a little bit of water. Because again, if you've got big, a lot of water coming through here up against this, you better be putting a tile in to get that water out and around that toe wall, not building up behind it. The only other reason that you might not want to use geotextile here is if you have those problem soils we mentioned before. But again, most of the time we're doing a geotextile here anyway. But I just wanted to point out the filter stuff that's listed on the drawing right now needs to be redone. All right, just an example of, this is sinkhole drawing. They're calling specifically out for a class 3 non-woven. Well, on a lot of our drawings, we're just saying geotextile, or we're saying, oh, a class 3, or, we're not so specific. Why is it so specific here? It's because class 3 has superior drainage, and, you're not, class 3 isn't very strong, but you're not dumping heavy, clunky rock on top of it. So this is a perfect application for a less expensive, less weight non-woven geotextile. You don't, it's not really under a lot of stress, but it's really good at letting water through. And for sinkholes, that's what we want. We want water to be uh, getting through here both ways, up and down. And class 3 is good for that. We don't want to, something where the geotextile isn't letting enough water through, for example, and it's building up a slurry here, and then it becomes unstable, and that creates issues on its own. Um, you know, Typically a class 3, and I guess you could use a 1 or 4 if the contractor used a 1 or a 4. It'll be okay unless it's in a waterway, because we tend to have more water coming down through these, obviously, in a waterway. So, but always try to use a class 3, but you don't have to rip it out if the contractor used a 1 or 4. So when should geotextile be used instead of extra subbase under a road? And more like, probably stream crossings fall more into this. Separation requirements, for example, for a road, for whatever reasons, or for any application. If you had a separation issue that you had to stay 2 feet from groundwater, this is an application where you could use geotextile to limit the depth that you have to dig down to. Additional sub-base materials can be cost prohibitive sometimes. Hauling in extra rock. Geotextile will cut down significantly on the amount of gravel material or granular material that you have to bring in. Geotextile is a great application for poorly drained soils that are soft. This is more for the stream crossings, most likely, but you can run into this in access roads when they get down into a low spot. A good application for it, just to kind of provide that extra reinforcement. It's worth its weight in gold sometimes if it works with your soils. And as I mentioned before, some stream crossings, where it's pretty darn deep before you get down to something firm, you'll want to probably use a geotextile there. So again, as far as geotextiles go, you always got to be watching out for those soils that can cause problems, because if those geotextiles clog or get blinded, they're going to create more problems than they're worth. Okay, so we go out on a site and the contractor said they're using this type of geotextile, and they use something completely different. Do I have to have them rip it out? Probably not, because especially for non-wovens have a lot of leeway on where they can be used and what they can be used for. Filtration. Now, if filtration is critical, and let's say, you called for a class 3, they put a class 4 in, and it had a permittivity of something less than 0.7, that could be a problem. But you don't have to have them rip it out on that sole purpose alone. That's where probably contacting area engineering staff to look at some other features of that geotextile. For example, the apparent opening size might be something we could work around. Now, if they put in a class 2 and they didn't put that sand cushion on it, that could be a problem, because they may have punctured the geotextile. Now, if you were calling for a class 1 or 4, which is the heavier weight stuff, and it can take more of a load, it can take more of a, rock drop height, and they put in well, not even a class 2, because that would have to be protected, but a class 3, that could be a problem, because it could, again, a class 3 punctures more easily than a 4 or a 1. Water flow, again, if they put in needed a class 3 and it wasn't used, and water flow is really important. Another thing you got to scratch your head and maybe talk to your area engineering staff to see if you can accept what they put in instead. Wovens, we're not going to see this a lot, but it's kind of the same thing. It most likely will be okay. Now, if it's a woven used instead of a non-woven or vice versa, like if you specifically called for a woven and they put a non-woven in or vice versa, you really need to consult your engineering staff because these can be so different between woven and non-woven. Again, it's kind of the same thing as the non-wovens if they're just switching up classes. You could probably use substitute some of the classes in, but again, talk to your engineering staff about that. So, all right. So I talked earlier about using geotextile behind riprap, but I also said, we don't really do that. And part of it is because how steep these banks are. We really don't need a filter, or I'm sorry, a fabric that rock can slip on. And the wovens will be worse than the non-wovens because wovens are made of plastic and they're really slippery. Non-wovens can, get somewhat of a bond going, but we almost always thicken the rock. And these are the options from the stream bank spreadsheet. We almost always just thicken the rock, option 2, 3 times the D50, and it's an easy fix and it works great. But I don't know that a lot of people know this, but these options only they're saying that there's no significant bank seepage. So once in a while we'll go out and there'll be, groundwater coming right through this bank and there's significant seepage going on. That's a case where thickening the rock is not a solution. You have to look at things like using a geotextile or using a filter. And as far as this drawing goes, this bedding is different than filter. Filter is where you put sand designed for the soil, a granular sand filter up against the soil. And you put the rock on top of that. There's no geotextile here. And the reason you might do that instead of geotextile is because these soils are problematic for the geotextile, or you have a lot more drainage through this bank than geotextile can handle, or you're afraid that the soil will clog the geotextile and it'll create bulges in your geotextile and fail the rock. So that's the situations you might want to use a filter, the granular filter instead of geotextile. Now, the problem with granular filters is, of course, this sand is a lot smaller than the riprap, and you got to put another layer of a little bigger rock and maybe a third layer of another bigger rock, and then the riprap on top of that. So these aren't the greatest solution either. 9 times out of 10, maybe 95% of the time, we're just thickening the rock and calling it good. But again, you can't do that when there's significant bank seepage. So woven or non-woven? As far as NRCS projects, non-woven is cheaper, almost always meets our requirements for strength, and certainly meets our requirements most of the time for drainage and filtration. It's drainage and filtration for non-wovens is superior to wovens. Wovens have superior strength, but we're not seeing a lot of woven usage here because we just don't have the type of loads and uses like wall reinforcement that a woven might be used for. Wovens are slipperier, so we don't want to be using them on slopes necessarily unless it's a really steep slope and we're using it basically as the wall. There's applications for woven in that case. Excuse me just a second. All right, thank you for waiting. All right, a few other things. One of the on manufacturers' data sheets, they sometimes show something called the sew seam strength. Well, why doesn't NRCS usually sew the seams? Well, it's because we overlap it. Now, if you were using a geotextile for wall reinforcement, you would want to sew it in that case because that is a more reliable connection between the woven, different layers of, or different rolls of woven as you're laying it out. Now, another situation might be, if you're using geotextile as instead of a granular filter around a very critical structure, for example, which is not something we do here, but that could be another reason you'd want to sew the seams. It's when you absolutely have to have those seams connected and that you don't want any opportunity for soil to get between those seams and migrate through the geotextile. As far as ASHTO goes, seam sewing should always be done on soils that have a CBR, which CBR is the California Bearing Ratio Test for all the engineers out there. You can get CBRs of less than 0.5 is basically muck. And so that's why we're just not seeing a lot of sewing of the seams in Wisconsin, or not at all. Is because we just use if we feel like there's an issue with it, we, instead of overlapping at 18 inches, we overlap at 24 inches, or we overlap at 36 inches. We just increase the overlap here instead of sewing seams. Another thing about geotextiles, you don't want to be wrapping the pipe, tile sock, or taking a perforated tile and wrapping it in geotextile. It's just not a good practice, and the manufacturers of the geotextile would completely agree with that. The preferable option is wrapping the trench in geotextile and leaving the pipe unwrapped, and then just putting granular material. You get far better drainage. So the only thing when you're putting drain fill around a perforated pipe, is to make sure you're not getting too small. A 3/8 up to 1.5 inch for the drain fill works great. You start getting smaller than that, it can get into the perforations of the pipe. Just a side note on drainage for pipes. So a couple more slides on geotextile. I just wanted to kind of summarize. All right, how do I pick a geotextile? Well, first, you verify the soils aren't problematic, as I mentioned before. Definitely don't use geotextile with these soils. Use a granular filter. Again, it's those non-cohesive silts, dispersive clays, gap graded materials, all bad. Determine if the soils are considered soft or firm, poorly or well drained. We talked about this with access roads and with stream crossings. You have to know, do I have well drained soils, or do I have poorly drained soils? Do I have soft or a firm foundation? And then decide from there what you need to use. Go into Spec 13 and EFH Chapter 17, Wisconsin Supplements. Look at your use category, select, building a road, Class 4 woven, or Class 4 here. Determine what your drop heights are. If greater than 3 feet for slopes, typically riprap, or 5 feet for the other projects, you're going to have to either increase the survivability criterion, which is like the tear strength, the puncture strength, the tensile strength. And then you make a decision, woven or non-woven, and almost always it's woven for us. So that's kind of just the decision process on what geotextile to pick.
Hey,
Construction
Janet,
could, yeah,
I do have a question.
sure.
Are sock wrapped tile appropriate in any NRCS projects?
I would say no, because sock is essentially a geosynthetic or geotextile. So no, I wouldn't use sock wrapped. I would use, let me just back up a couple slides right here. Put the geotextile, if you're going to use geotextile, put that around the trench, make a trench and fill it with stone and put the tile in there. You'll have much less problems with clogging. Does that answer the question?
I think so.
Okay, great. Construction considerations. All geotextiles always have a well-prepared subgrade with no rills or depressions, overlap, as per the specification. This is a rock chute that failed. What happened is the geotextile with high velocity flow down the rock chute, it got pulled up by purely suction from the water flowing in and on top of the big rock. It pulled that geotextile up. It lost what we call intimate contact with the soil, and it created a slurry underneath, and it was very unstable. And this is what happens. So intimate contact is really important between geotextile and the ground below it. Don't have depressions, don't have wrinkles. Um, you know, key it in, and on things like this and on riprap, you want to key it in as you're going down the slope. That's a great idea to key it in as you go down the slope. It just keeps it taut so that it's keeping good contact with the soil. Intimate contact is so critical with geotextile. The other thing is putting a bedding layer between the soil and the geotextile. So underneath this geotextile, put a sand layer, because that just, sometimes when we grade for these rock shoots, for example, that ground is really firm and it's really hard. Whereas if you put a sand layer in there and do some compaction on it, it's just a much better backing for this geotextile than just bare earth. Let's see. So the other thing with geotextile and putting it on a slope is when you start to get really big rock, 8-inch D50 and bigger, that gets really big. And then you don't have enough rock, or you have too much void space, and it's not holding this geotextile down against that soil because you got so much void space. And then this high velocity flow comes over and it's sucking up the geotextile away from the soil through those void spaces because your rock is too big. So you don't want to put really super big rock. And this goes for stream banks too, on geotextile without putting something over the top of the geotextile to hold it down. All right, subsurface drainage. That class 3, we can't drop anything greater than 10 feet on it, and it can't be sharp, big rock riprap. And typically for subsurface drainage, we're using that 3/8 to 1/8, 1.5-inch rock, so it's fine. But remember that you don't want to be dropping big stones on class 3. Road stabilization, again, light to medium loading, both weight and frequency of traffic, which NRCS projects, that's what we're all about for access roads. If you have a soft subgrade and rutting during construction, increase your overlap or fill those ruts in, and also, if you can't get them filled in perfectly or whatever, increase your overlap. All right, so when shouldn't I use geotextile? Well, it can be used in a lot of practices as we've seen, and you can safely use it. But there are problem soils. Again, I've mentioned, mobile fines, a gap graded, dispersive, dirty water. Those are where you wouldn't want to use a geotextile. Also, when you feel like, you've got too high a velocity, like a rock or block shoot, um, you don't necessarily have to throw geotextile out the window, but you need to look at your conditions and determine if geotextile is appropriate for that, or is it going to get sucked up off the soil from high velocity flow and you're going to lose intimate contact. Again, don't place on a problem soil. Remember that geotextiles are really thin, 2 to 3 millimeters versus a granular filter, which is 6 inches. It's 150 millimeters. So you get a lot more flexibility with granular filters and a lot more longevity too, I believe, just because they're so much thicker. And don't use geotextile as a filter or a drain in places that are hard to reach. So if you're building, putting a tank in the ground and you're 10, 12 feet down, that's going to be a real pain to come in and fix. Drain diaphragms in a dam, we just don't use geotextile in our dams anymore, anywhere. We may have used in the past a sock wrapped tile in a drain diaphragm in a dam, but wouldn't want to do that either. That would be a real pain to have to go in and fix that. So that's kind of your mantra, is that if it's really hard to reach and expensive to repair, don't even consider geotextile if it's used as a filter or a drain, because it could clog. So granular filters, just got a few more slides here left on granular filters. Essentially, they're placed in embankment zones. Drain diaphragms are a great use for them, and they will help fix a situation like this. We oftentimes use collars on these, but drain diaphragms, which is a sand filter, essentially a granular filter, will seal cracks up better in an embankment around a pipe, and they're superior to a collar that's put around these pipes. So that's a good application for a granular filter, is a drain diaphragm in a dam. Essentially how they work is, I used to work for a beer company, and, we use ceramic filters, and it's the same process. You got you building up a filter cake. And, that's what's happening when these filters are first put into action, is that It's slowly building up a filter cake that increases its filtration capabilities, and that's what's providing the filter, and it stops cracks in their tracks, basically. So by building up that filter cake, and that's where they're successful in in dams. Is, when you first you build a dam and you first fill it, there's going to be cracks in the soil, just because it's all compacted, and compaction, isn't 100% perfect. You're going to have cracks coming through there. Well, it stops them in their tracks and maintains the integrity of the embankment. Let's see. So granular filters provide filtration first, which is keeping soil in place, and drainage second, meaning its first priority is to keep soil in place so you don't have fines migrating through and you end up with a pipe that's exposed in a dam, like I showed in the previous picture. You can use them with the soils that geotextile has trouble with. The gap graded, the mobile fines, the granular filters can still be used for those. Sometimes we have to use what I talked about in the riprap when when you either cushion geotextile in riprap applications on a slope, or you use a sand filter. You have to build your way up with different types of rock, different sizes of rock, because you've got a really big clunky riprap here. And so that's why these graduated granular filters can be used, but they're kind of a pain because you got to bring out 2, 3, 4, sometimes different types of rock. And that's called a graduated granular filter. So where does NRCS use these? They're going to be used in our line chutes, meaning the rock and block chutes. They are used in 2-stage drains around structures, and they are used in drain diaphragms for our dams. Okay, where do I go? How do I know how to design a granular filter? It's this one right here, chapter 26. NRCS Engineering National 633, Chapter 26. That's where you go. And this is where it's found in E-directives. You do need a gradation analysis from a lab. I heard lately that Onalaska is able to maybe do just gradations. Atterberg and all that other stuff, they're not so much able to do because of time, but they can usually get you, 3 to 4 or 5 weeks, get a gradation only done for soils. So that's probably your best option. Again, chapter 26. And there's also a spreadsheet that was created by the Soils Lab in Lincoln that's really handy to use for this, but it's not something that's out there for everybody to use. It has to be used with the assistance of the area engineer. Because it can, it has a lot of caveats with it, a lot of things that if you don't know what you're doing, you can turn out to have something not well designed. So there is a spreadsheet, but contact your area engineers for it. And this is just a printout from the spreadsheet. And essentially, what it does is you put in your base soil gradation that you get from the lab. So here you'll get this from the lab for what your soil is. You'll put that in, that's this line. Then what this program does, or what the spreadsheet does, is it creates filter bands, meaning this is your lower filter band width, or your filter band, this is your higher. Now, in this case, these 2 red lines is a C33 gradation. So this is the lower limit for a C33 sand. This is the upper limit. If it fits in between this line and this line, you're good. ASTM C33 sand will work. You're good. I need to pop out here just a second. I've got to go to my spreadsheet, so bear with me for a minute here. Switching screens in Zoom is a little challenging for me. I'm used to Teams, so bear with me for just a second here. All right, so we're going to bear with me for a little longer. My X is covered up. There we go. Kelly, do you know how I've got my screen, I can't get up above here to. Are you there, Kelly?
Yeah, you
Yeah.
might have to start a new screen share to switch over to a different monitor or window.
Okay. Well, let me just see if I can cover this up with something here. Sorry about this. I had it all open, but I'm just having trouble getting it into the right spot. Can you guys see my screen now? Can you see a spreadsheet?
We still see your PowerPoint, it looks like.
PowerPoint? Okay. Um, okay, so let me, like I said, I'm not real good with Zoom here, but let me, yeah, you know what? Let me do it this way. I'm just going to clip it and you're still seeing my presentation, correct?
Correct.
Okay, thank you, Jean. Do it this way instead. All right, can you see my presentation still?
Yes.
Okay, so this is one where, just wanted the spreadsheet shows you what your filter bandwidth is. And as long as what you want to use out there as a filter material, the ASTM C33 sand in this case, falls between this boundary, you're good. Now, is that always the case? No, and this is what I was going to show on a spreadsheet. This is sometimes you'll put in your gradation, your base soil, which is this line. This is your filter limits right here, the green line and the blue line in this case. These are your filter limits. That C33 sand that I'm picking up here, yep, you know what? I bet you guys can't see what I'm pointing to, right? There we go. Okay. Base soil. Can you guys see my
Your hand
pointer?
we can see.
Okay, great. Thank you. Okay, so you've got your base soil in here, you've got your filter limits, but the C33 sand does not fit. Just the upper limit of the C33 fits in here. So that's a problem. You can't just say, hey, let's use C33 sand because it doesn't meet your filter boundary. The other thing is, and this is where knowing how to use the spreadsheet and understanding chapter 26 is this is a problem too. You don't want a filter boundary that does this. It should just kind of be more of a consistent line here. So you need to know how to fix this. And this is where the area engineers and the area engineering staff come in is, okay, let's fix this first, get your filter bounds, and then let's find a gradation that will fit in between here. This is an example of a poorly graded sand that we had at a site that ASTM C33 will not work with. I just wanted to point that out. It doesn't work with everything. And that's important because a lot of national publications and even some in our state say, hey, C33, just use that. It doesn't always work. And I just wanted to point out what situations that might be the case. Poorly graded sands or also some sands with silt, meaning if it's sand with a little bit of silt in it, those could be a problem too, that C33 won't work. You will have to go in and make a sand gradation that fits between your filter boundaries here. You can, you can do that. You can spec out your own kind of sand. And that sand is available because we actually ran into this situation last year and we had to spec out a sand and the contractor was able to find it without too much trouble. A sand that we spec'd out specifically that fit in between the filter boundaries we were working with. So, cautions. As far as granular filters go, we say, hey, use this ASTM C33. They come back and give us a sand gradation from the quarry that's not even close to a C33, and then it doesn't fit. And we put it in here and we can actually put in what the quarry gives us for gradations for their upper and lower limits. We can show it here. And if it doesn't fit between these lines, it's not going to work. Now, that's where having knowledge about chapter 26, this design method is important because when these filter boundaries are created, from the default input from the spreadsheet, that's just the defaults. You can tweak some of the numbers to move these boundaries around, but you need to know what you're doing. And that's why we need area engineering staff to be involved, because if you don't know, if you're tweaking numbers and you don't know what they're doing, you can have a really bad filter. So the spreadsheet's great. It's really easy to use, but you need to know what you're doing with it. But if you ever have the need for a granular filter, I would definitely recommend it, because if you do go into chapter 26 and try to do it the longhand way on paper, it's pretty complex. So again, don't always assume that C33 sand is going to work with all of your soils. The other thing I wanted to mention about in publications for NRCS is they often say, hey, you're using C33 sand as your filter, then you can put ASTM number 67 next to that. That's not always a good call, because the 67 is a little too big for the C33 sand. Could it work? Yes, but if you have a critical site, use the smaller stuff, the 8 or the 89. The 8 is more of a pea gravel. That's much better up against this C33 sand than the 67, which is more of a gravel. All right, just wanted to quickly show you, out in the field, you got your base soil, your filter sand. Instead of a geotextile providing the filtering, you've got a filter sand here that's designed according to chapter 26. Then you've got the drainage layer for a 2-stage drain. And this is basically keeping the soil out of the drainage layer. And so this is what is a typical two-stage drain. This is your first stage, this is your second stage. And you'll see that some of the sand has gotten down in here. That was just purely from, using a glass vase here to make our example. But typically that sand maybe migrate in a little bit, but if this gravel layer is designed properly, like maybe a number 8 pea gravel would have been better here. I think this was more of a number 67, a bigger gravel, or not a big gravel, but a gravel. You'll get some migration down through there, but eventually that will stop, and the rest of this will be a lot, pretty clean for draining. That's it. Are there any other questions that people maybe want to turn on their mic for?
I don't have any new questions in the chat.
I'm not sure that's a good thing or not a good thing, but all right. Well, if there's no questions, again, I just want to say, if you ever have geotextile questions or granular filter questions, just contact me.
We do have a hand raised from Stacy.
Hey, Janet, can you hear me?
Hi, I can.
Hi.
Thanks.
Thank you. I have a
sure.
question, just how NRCS, with respect to stream bank riprap. And I know that the easiest answer is to go with 3 times the D50 for the rock thickness and just avoid a filter or a fabric at all. But there's instances, I guess, where if it's really remote, or if 3 times the D50, puts you at some crazy thickness. I guess I'm just curious. I hear a lot of times that, NRCS does not want to use a geotextile in a stream bank situation. And I definitely recognize it's not always easy to use it with the flowing currents and whatnot. But what is the best answer to that? Because it doesn't seem like a granular filter and the chapter 26 option is really that friendly in the field when you're trying to place it in a stream either. So is really the final answer, or the only answer, that we have to be 3 times the D50?
No, not necessarily. If you were using geotextile I think what you're saying, Stacy, is hauling more rock because it's a remote location gets expensive.
Yes. And
Yes,
just
right.
the tremendous volume of rock is expensive right off the bat, not to mention getting it to where you need it.
Yeah. So, 3 times the D50 has been proven to be a reliable way to put in riprap. No question about it, right? And at steeper slopes, I mean, 1.5 to 2 to 1, right? But if you're in a situation, where you have a lot of seepage maybe, or you've got a lot of cost to haul in that extra rock, you know, you can use geotextile and it can be successful. What I would do is I would flatten that slope to 2.5 to 3. I wouldn't put it in at 2 to 1 necessarily, because that's pretty steep, you know, and it's a fabric, so it's going to be slipperier than putting the rock on soil. So I would, you know, go to 2.5, maybe 3, because you're saving a lot of money on hauling rock. So a little more earthwork if it fits the site. Flatter slope, use the geotextile, key it in as you go down the slope so that you're not just going the entire slope without keying it in at all. Maybe go down 4 or 5 feet, key it in.
Okay,
And,
thank
you
you.
know,
So,
sure.
so it does sound like NRCS is not simply stating thou shalt not use geotextile in streams. That is not the case.
No,
Okay,
no, I
thank
don't think
you.
we're saying that at all. I think there's been a bad history about them. I think their belief is when they were used is that rock slipped off of them. I don't think it was so much that then, you know, it probably was to some extent. It's just not going to be as good of a bond, right, with the rock. But again, if you go flatter on that slope, I think it's going to be fine, and you key that in, and you don't have those problem soils that I talked about, which is unlikely. You should be fine. But I wouldn't use it. I would always 3 times D50, like I said, proven. Use it if you can.
Thank you.
Sure, Stacy. Good question.
All right, Janet, we got a couple more questions in the chat.
Sure.
I'm going to go with Brady's first because he's talking about 3 times the D50 thickness. He wants to know, how does 3 times D50 thickness of large stone with large pore space hold back fine soils as geotextile would?
Yeah, so that's defined in EFH chapter 16, Wisconsin supplements, Brady. So if you really want to know the full story on it, go to that. But essentially, you know, it's what's happening here is you're thickening the rock, and this is important. You can't have, if you call let's say a 10-inch D50 and you go out there and it's 15 or 16 or, you know, that's not good. You want to first make sure you got the gradation that you called out and nothing bigger than what you called out. The other thing is, you know, a gradation. You got to have that smaller stuff in there. So when you go 2 times the D50, you know, you'll have a certain amount of void space in that rock. When you go 3 times D50, that void space is going down. With every thickness you're increasing that rock, the void space is going down by the mere fact that you've got a good gradation, and that little stuff is getting in there. It's just got more opportunity to get in there and keep those void spaces small. And it's called leaching potential. And again, you know, chapter 16 that I mentioned is going to talk about no significant seepage. So you can't have water boiling out of that side hill and try to use 3 times D50, because it's going to carry those fines through that rock. You know, this is all based on, you know, normal seepage through a bank is okay, but nothing that's crazy for seepage. Then you probably need to look at a geotextile. And like I said before, flatter slope would be better. Keying it in, going down the slope would be better if you're using a geotextile.
All right, thanks, Janet.
Sure.
Last question that I have in the chat so far is, are the silt loam soils in Southwest Wisconsin considered a problem with geotextile?
I don't know. That's a great question for a soil scientist, because what you're looking for is dispersive clays, or what we call mobile fines, silts that don't clump together. And I don't have a soils background, so I can't answer that question, but that's a great question for soil scientists. Typically not, but could it happen? Yes, it could happen anywhere.
All right, that's all the questions I have in the chat unless somebody raises their hand.
Okay, I think we're good then. Thank you, Jean.
Yep.
Thanks everyone for attending and for the questions.